Hello everyone, welcome to the Codecraft channel. In this video, I'll give a brief overview about the exciting field of AI and how it can be used to solve real-world problems. Over the past year, a new type of artificial intelligence program called large language models or LLMs have emerged. You may have heard about chatbots like ChatGPT that can write blogs, emails, or even plan vacations. This represents a big leap forward in what AI can do. What are foundation models? Large language models belong to a broader approach category of models called foundation models. The LLM or large language model is a specific instance or implementation of a foundation model. Think of a foundation model as the broader concept, a powerful architecture designed to understand and generate human-like text based on its vast knowledge. The LLM, on the other hand, is a specific version or instantiation of that architecture. LLMs are trained using the foundation model architecture. They are built upon this foundation, leveraging its capabilities to process, understand, and generate text. So, while the foundation model concept encompasses the general architecture and idea, LLMs are specific models built on that foundation, utilizing its abilities to perform language-related tasks with a high degree of proficiency and flexibility. The idea of foundation model came about when a team at Stanford noticed a big change in how AI was growing. Before, AI was made by training different models for different jobs. Each model learned very specific things for very specific tasks. But this way had limits. They had to make separate models for every task without a flexible system to handle them all together. The foundation model could handle various tasks. Unlike the old AI models that were only for one job, this foundation model could do the same task as before. What made these foundation models really special was how it could easily switch between different tasks, which was a big shift from how things used to be. Its superpower came from learning a ton of information without anyone telling it exactly what to learn. This huge amount of learning let the model understand patterns and context really well. Think of it like this: if you give the model tons of text to read, it gets really good at guessing the missing word in a sentence. It learns from all those words and can predict what should come next based on what it's learned. For example, I might start a sentence with Virat Kohli is one of the best and want the model to figure out the missing word like cricketers. This ability to predict and create new words or sentences is why these foundation models are part of a special area in AI called generative AI. It's all about making something new, like guessing the next word in a sentence based on what it has learned before. In simple terms, foundation models in AI are like super smart students. Imagine a student who spends years in school learning all sorts of things, basics like math, science, history, and more. These are like the foundation of their knowledge. Similarly, AI foundation models start by learning from huge amounts of data, like billions of web pages or images. This is their school phase, where they build their core skills by understanding a wide range of information. After this phase, just like the student who later specializes in, let's say, becoming a doctor or a lawyer or an engineer, parts of the AI model gets retrained for specific tasks. Some parts might specialize in summarizing text, while others might focus on recognizing objects in images. This specialized training happens after they have built a strong foundation of general knowledge. If you add a bit of label data, you can adjust these models to do typical language tasks like sorting things into groups or spotting specific names, tasks that aren't usually linked to models that generate content. This adjusting process is called tuning. You can fine-tune your foundation model by adding a small amount of data. This update helps the model focus on doing a very particular language job. Even if you have limited data or almost no data, these foundation models still do a great job, especially in areas with very little labeled information. Through prompting or prompt engineering, you can use these models for those exact same tasks. For instance, you could ask a model to decide if a sentence sounds positive or negative. The model tries to finish the sentence, and its next word is the answer to your question, either positive or negative, based on how it feels about the sentence. These models surprisingly perform really well when you use them in these new situations and fields. Let's break down the upsides and downsides of these models. One big advantage is their incredible performance because they have learned from a massive amount of data, like a whole bunch of information which worth terabytes. This learning helps them do small tasks way better than models that only learn from a little bit of data. Another plus is productivity. They need much less label data to do specific jobs compared to starting a new model from scratch. They are smart because they use all the information they learned earlier, even if it wasn't labeled. But there are drawbacks too. One is cost. It's really expensive to train and use these models, especially for smaller businesses. They need lots of computer power, like fancy GPUs, to even run. The other downside is trust. These models learn from tons of internet data, which might include bad stuff like hate speech. Even with a team of people, it's hard to check every single piece of data these models learn from. So there might be biased or not so great information in there. Sometimes we don't even know exactly what data was used to teach these models, which makes trusting them a bit tricky. So far, I have only discussed examples related to language tasks, but the truth is, foundation models can be used in many other areas too. For instance, there are famous models designed for vision tasks, like DALL-E. It uses text data to create unique images. Additionally, there are models meant for coding, such as GitHub Copilot and AWS Code Whisperer, which assist in writing code as you work on it. Let's look at some factors to make a choice between LLM and foundation model. I would go for LLM when I need a pre-trained, ready-to-use language model that can perform a wide range of language-related tasks, or when I see rapid prototyping or quick implementation is required without significant fine-tuning or customization. And I would go for foundation model when I require more customization or fine-tuning for a specific task or domain, or when I have access to significant computational resources for training a model from scratch or adapting an existing model extensively, or when I aim to develop a specialized model tailored to a particular use case or domain-specific requirements, I would go for foundation model. As a programmer passionate about AI, I follow news from across the industry about enhancing efficiency, trustworthiness, and accessibility of foundation models to unlock their benefits fairly and securely. I see exciting times lie ahead. While much current focus is on natural language models, I think the biggest breakthroughs could emerge from expanding this approach across disciplines like computer vision, scientific research, finance, or medicine. We are just beginning to grasp the possibilities of adaptable, multi-purpose AI. I encourage you to explore foundation models more as they stand to transform technology and society over the next decade in potential profound ways. The risk exists, so do immense opportunities if we forge ahead responsibly. Thank you for watching my video. If this information brightened your day, give it a thumbs up and spread the knowledge by sharing.